So in this lesson we're talking about changes of state, and this will be review for many grade 9 students. But we're going to go through the 6 changes of state. We're going to talk about when heat is added, when heat is taken away, and we're going to give some examples for each change of state. All right, so when we have a solid and we add heat to it and it turns into a liquid, this change of state we would say is melting. Okay. Sometimes it's also called fusion, but that term is not commonly used. So we refer to this change of state, solid to a liquid, as melting. The change of heat, of course, is that you need to add heat in order to make this change of state added. A few examples for those of you that do any cooking. Solid butter is heated in a hot pan. You, of course, notice that it melts into liquid butter. A solid ice cube in a warm glass of soda will absorb the heat as it melts, and because it's absorbing the heat from the pop, it will cool the pop down. So this is melting, and very closely related to melting is what we call solidification, and most commonly we know this as freezing. Okay, this is where we have a liquid and we remove heat and we end up getting a solid. So this is the opposite of melting. Freezing and melting are opposite processes. And the heat change is that we remove heat from our sample and it goes from a liquid to a solid. So a few examples of this is that we remove heat from the water in an ice cube tray. When we place that ice cube tray in a freezer, that's what happens. Heat is being removed. The water then freezes, and excess heat, all the extra heat that's taken out of the water, is usually released to the air in behind the freezer or in behind the fridge. And that's why typically the back of your fridge will be quite warm. It's because all the excess heat is being released. Just a little note, freezing is usually referred to discussion of water, or really anything that happens at very cold temperatures. But some things will solidify at room temperature. So it would be very odd to say that liquid chocolate freezes into a bunny mold. So we would use the proper term. We would say liquid chocolate solidifies into its bunny mold. And really anything that happens kind of at room temperature, like it would be weird to say that liquid iron freezes to become solid iron, because it's not happening at a cold temperature, it's happening at a very hot temperature. So we would use the term solidifies. All right, so 2 different processes now, and we're going to talk about going from a liquid into a gas. So we call this vaporization. That's the term. If it happens slowly, then we're discussing evaporation. If it happens very quickly, then that's boiling. Okay, but these 2 terms are under the same umbrella, and that's vaporization. Here we have liquid, and we're adding heat to the liquid to get a gas. The process here is that heat is added. So a few examples. Water, which really is what your sweat is on the surface of the skin, will absorb heat from the body. Okay, so when you're warm, your body will give off liquid water, right, which is what we call sweat. And that sweat, that water that's on the skin, will absorb heat, and that will cause the liquid water, the sweat, to vaporize into a gas. And so what ends up happening is heat is removed from the body and you cool down. And that's one of the reasons why we sweat, to maintain our temperature. So it's many, of course you could think of many examples of vaporization. We'll talk about condensation next. Condensation is the opposite of vaporization, so these two are linked. Condensation is where we have a gas and we remove heat and we end up with a liquid. Okay, so heat is removed in this process. And an example that we've chosen for this one, when water vapor hits the side of a cold glass of soda, heat is removed by the vapor and it condenses into liquid. So this is often what will happen in the summer when you've got a really ice cold glass of something to drink. You'll notice that you get droplets on the outside of the glass. And that's because water vapor in the air is condensing. So it hits this cold glass, heat is removed from the water vapor, and it becomes liquid water in the form of droplets. All right. So the last two changes of state involve going from a solid straight to a gas. And this change of state has the term sublimation. And in sublimation we have a solid which is heated and it turns into a gas. Okay, so almost right away. A solid which is heated turns into gas. So the process here is that heat has to be added to this. So an interesting example is that after a long time being stored in a freezer, ice cubes will decrease in size because water molecules are lost from the ice cubes as the ice sublimes in the freezer. Okay, so as the ice, sometimes you'll notice this when you open your freezer door and you look at the ice cube tray, you'll notice that the ice cube tray it's giving off water vapor, and it's because that solid, because of the change in temperature, heat is being added from the atmosphere when you open the freezer door, and that ice is subliming. So those will get smaller, those ice cubes will get smaller and smaller because we're losing parts of them. The opposite of sublimation, which most of the time is also just called sublimation, but we're going to say something different. We're going to call it deposition, because that's the less common term, but it at least means that we don't have the same word to describe two different processes. Deposition is where we have a gas and we remove heat and it becomes a solid. And this is the process here, is that heat is removed. And this we've all experienced, you know, living in Canada. On a winter day, if you breathe on a very cold glass window, you'll get frost that forms as the water vapor in your breath sublimates or deposits onto the gas. And that's going from water vapor right to a solid. So when you breathe onto a very cold glass window, you'll notice almost right away that there's a frost that forms. So a few notes about this. In order to smell a substance, it must be in a gaseous state, or it must be in the state that is a gas, so that those molecules of the substance can diffuse and can attach to smell receptors in your nose. So if you smell something, that means that it's present in a gas state. So this is some interesting, there's some interesting consequences to this. So if a liquid has an odor, if you can smell a liquid, that means that it must be evaporating at room temperature. So when you have a liquid and you're smelling it, it means that it must be evaporating if you can smell that liquid. So examples of this, and I'm sure that you can think about some, are vinegar and acetone. So two substances that when you smell them, they're liquids. Well, you can really smell those liquids, but that means that they're evaporating, right? Alcohol is another one of these things that has that property. Gasoline. A solid that has an odor then must be sublimating at room temperature. So if you can smell a solid, then it must be sublimating. So think about this. There's lots of things like those really stinky candles at Bed Bath and Beyond, or whatever the heck it's called, or Vicks Vapor Rub, or when you were a kid and you were in the junior grades and your teacher brought out those Mr. Sketch markers that smelled really, really good. Well, those are predominantly all different types of solids that have an odor, so they must be subliming. And a few other just small things. Room temperature is, of course, 23 degrees. We've talked a little bit about room temperature. Is body temperature 37 degrees. So these last two exercises, this down here, the diagram, and this little review sheet right here, these are to be done in class or for homework, whatever the case may be. You could work on them now after you've finished, or you can do them kind of when you're directed to do so in class. But they just summarize the particle theory, and they kind of put the particle theory and changes of state in context, so that all of this is happening because of reasons in the particle theory, and we can use those two things to really tie some ideas together.